Today, let's review a easy question that is a precursor to number one, which is twosome, that I think I solved a while back. Looks like I got a lot of wrong tries, so let's try to see if I can solve it again about 5 months later. So this question asks you to design a data structure that accepts a stream of integers and checks if it has a pair of integers that sum up to a particular value. So, okay, so implement this class called twosome, which we want to initialize an object, which is an empty array or a list in Python. So let's go ahead and define that. Self.current, let's just call it this. To add the number, simply add it to the data structure. And then here we want to return true if there are any pair of numbers whose sum is value, and otherwise return false. So pretty straightforward. Why don't we just append number, right? Add it to the list, add it to the rear of the list. I don't think the order really matters. And then here, iterate over our array. So the pair of numbers cannot be equal. That's why j starts right in front of I. So for example, if you have an array like this, at every turn, I starts here, j goes to the end. I starts here, j goes to the end. And you keep doing this until you get here, or if j is out of bounds. So which it's going to be as soon as I gets here. So now let's just say if self.current of I plus self.current of j is equal to value, return true. Right? If we get through all these the nested loops and we never find a pair that sums up to value, then return false. So that will time out because this is not optimal, but let's try to use other ways of doing this. Okay, as you can see, time limit exceeded. So instead of having to basically do a brute force O of n squared solution, right? O of n squared, because the array times itself is how many times we're going to be iterating over in the worst case. So 5 times 5 times is 25. We can come up with a better linear time solution by using a dictionary, which is going to, similar to the original twosome problem, let's call this dictionary. And then let's look for a complement, right? Because complement is going to be what we need the other number to be to add up the target, which is just value minus self.current of I. And if complement is in our dictionary, then return true, right? Because usually twosome we just return the value in the index, but in this case you just return true. I remember that. And then if not, then we put the current number. Or yeah, we want the number, the value itself, and then the actual index itself, right? Or we don't even need that, but as long as a complement is inside of our dictionary, you turn true. At the end, if this is never true, you return false. So that should work. And there you go. So passes and avoids time limit exceeded. Again, if you understand twosome, this is going to make sense because in the first turn, for example, if I explain this, this is never going to be true because, well, unless the complement plus itself is equal to the value, because the value minus self.current of I is just self.current of I, which there's not another number in the dictionary because the dictionary is empty. So actually the first turn is never going to be true. And then we add it, and in the second turn, we're going to get to 2. And we're going to look in the dictionary, which is going to look like this. So we're checking the keys of the dictionary to see if the key happens to be equal to whatever value we need. So if value is like 4, then the keys in the dictionary, there should be a key in the dictionary that equals 3. For example, this number is irrelevant, but if it does, then we know that the current number, which is like, for example, 1 that we're seeing, plus this key can add up to the value, which is 4, right? So just wanted to explain that real quick. And if it doesn't, then we can add that to the dictionary and then keep going. But if it is true, then we just return true and we just stop everything, because that true comes back to the function caller and we don't keep continuing doing anything else, right? That's what the return statement does. So hopefully this video was helpful, and if you enjoyed this, please consider subscribing, and in the future, consider also hitting that like button and telling people about this channel, because I'm going to be going over a lot of different questions, over a lot of different topics that I've solved. I've solved over 1,000 questions overall. So, and yeah, if you enjoyed it, please consider subscribing again, and thank you for watching. So stay tuned for more.